Welcome to Rival Institute. Now discussing the variance of x. So what is the variance of x? So we need two random variables x and y. So we have a two random variable x and y. Variance of sum. So we can write variance of sum of x and y. So we have two random variable x and y. So sum of s plus y. So that is a variance of sum. Sum of s plus y. Variance of s plus y, we can write variance of x plus variance of y plus 2 times covariance of x comma y. So this is the formula for the variance of s plus y. So we have a variance of x is there, variance of y is there, but additional, we have additional 2 times the covariance of x comma y. So we can check how this formula, we can prove this formula. So we'll start with one of the variance formula variance of x. What is variance of x? We have one formula. What is a variance? Variance means this is a what is a change from the expected value. So square of the change of the expected value, s minus expectation of x all square. So same way, this is a variance formula we already studied in previous class. Same way we can write variance of s plus y. So same way we can write variance of s plus y, expectation of s plus y minus expectation of s plus y, this all square. So expected value of x, instead of s we written s plus y minus expectation of s plus y all square. So this is a variance of s plus y. So this one we can write, this one is equal to just a small modification, x minus, this one is inside we are giving s plus y minus of expectation of x minus of expectation of y, this is all square. This is all square. We are giving just expectation is given here, expectation of x and expectation of y. So this we can write here, expectation of x minus expectation of x, x minus expectation of x plus y minus expectation of y, this is all square. So we have written two terms like this one we can bracket expectation of x, same way we written, this is a big bracket is giving, this is a plus b, same way we written s plus y, x minus expectation of x, y minus expectation of y. So this is a plus b all square. So a plus b all square is equal to just taking here a, this is a, so expectation of x minus expectation of x, this is all square, x minus expectation of x all square plus 2 times x minus expectation of x and y minus expectation of y. So this is a 2 times ab, this is a square plus 2ab plus b square, that is y minus expectation of y, this is all square. This is total bracket is here, expectation. So this is the formula, this is rearranging, this one just for given the square, a plus b all square, a square plus 2ab plus b square. So rearranging here, expectation of s minus expectation of x all square, this expectation is given to here, this term, plus I writing this term here. So expectation of this expectation is expectation of y minus expectation of y all square, this expectation is given here, this expectation is given to here, plus 2 times expectation of, this expectation is giving here s minus expectation of x and y minus expectation of y. So this is the formula. Just rearranged. This term is written here with expected value. Here this expectation is given to here. Expectation is given to three places. So what is the value? H minus expectation of H all square. This one we can write variance of H. This is variance of H. This is plus variance of Y. This is variance of Y. Y minus expected Y. Plus this is we already studied. This is a covariance. 2 times covariance of S, Y. So this is the formula we proved. So is proving we start with the S minus expectation of S all square. Same way we start S plus Y minus expectation of S plus Y all square. And S plus Y is written here. This expected value is given here. Expectation of S minus expectation of Y all square is there. Just rearrange S minus expectation of X, Y minus expectation of Y. Just rearranged and total all square. This we can write A plus B all square. So H minus expectation of X all square plus 2 times AB. So this word is, this is A, this is a B, and this is a B square. Y minus expectation. This expectation is outside is given to each term. This expectation is given to each term. So expectation of S minus expectation of S square, this one. And here we got like that. This is our second way written, and this is that. So this is variance of S, this is variance of Y plus 2 times covariance of SY. So this is one of the method. We solved the variance of S plus Y is equal to variance of S plus variance of Y. We solve other way. One more method is there instead of here. This variance of H we can write variance of H we can write variance of H is equal to, we can also write like that one more formula we studied. Expectation of H square minus of expectation of H whole square. This is one formula we studied. Variance of H is equal to expectation of H square minus expectation of H whole square. Same way we can write here expectation of variance of S plus Y. Variance of S plus Y is equal to expectation of S plus Y. This is whole square minus of expectation of S plus Y whole square. This is whole square. So this we already studied expectation of S square. Wherever we are doing the problem, solving the problem, we will use this formula only. Expectation of S square minus expectation of S whole square. So variance of S plus Y we are writing expectation of S plus Y square minus expectation of S plus Y whole square. So here this is expectation of H square plus 2HY plus Y square. This is just A plus B whole square. We written like that. Minus of this one we can write expectation of H plus expectation of Y whole square. This way we written. This one is expectation of H, expectation of Y whole square. So here we can write again here. This one is inside we are giving expectation of S square plus 2 times expectation of HY. 2 times expectation of HY plus expectation of Y square. So this expectation is given inside. Here this is A, this is B. A plus B whole square. So what will get the expectation of H whole square. This is A plus B whole square plus 2AB. 2 expectation of H, expectation of Y plus expectation of Y whole square. This is A plus B whole square. Same way expectation of H is A, expectation of Y is B. So expectation of H square plus 2H plus expectation of H and Y plus expectation. This minus symbol is there. So minus is giving to inside. So this will become minus. This also become minus. So we expanded. Here we expanded expectation of H square like that. Here also we expanded. Now it's just rearranging. So rearranging, how can we rearrange? expectation of x square and taking minus of expectation of x whole square. So this 2 times is taken, plus expectation of y square minus of expectation of y whole square. So I taken this term and this term, plus 2 times, 2 is taken outside. This 2 is there, both place 2 is there. 2 is taken outside. Expectation of xy minus of expectation of x, expectation of y. So you just check it. Again we studied another one more formula. X square minus expectation of x square. So this one we can write up to here. It is a variance of x plus this is a variance of y. Variance of y plus 2 times this is a covariance of s comma y. So we have proved again. So expectation of s square minus expectation of s whole square. So this is one of the formula. We write expectation of sy instead of x we have written as plus y whole square minus expectation of s plus y whole square. Just this is a plus b whole square, we written like that. Same expectation is given here. And this is also a plus b whole square, we proved here. This expectation is given inside, so we got here, and rearranged. Here is rearranged expectation of y square is written here, and 2 expectation of sy written here. So this is variance of x, this is variance of y plus covariance of s comma y. So second way we proved the same formula, second method we proved it. We can prove once again. One more method is there. This is a covariance method. So this one you can write variance of x. Variance of x is writing variance of x, we can write covariance of x comma x. This is a covariance of x and x. This is a variance of s, will write like that, covariance of x. So variance of s plus y, variance of s plus y, we can write covariance of s plus y, s plus y. So this is the covariance of s plus y, s plus y. Variance of x, we can write covariance of x, x. Same way variance of s plus y, writing s plus y, s plus y. Now you see covariance formula s plus y and s plus y, we can write like that. This is equal to covariance of x comma x plus covariance of x is given to first here, then x is given to first here, x and y, plus y is given here, y is given here, covariance of y comma y, y and y comma x, first y comma x plus covariance of y comma y, y and y. So now you see this is rearranged covariance of x comma x plus covariance of y comma y plus this is 2 times covariance of s comma y. This is covariance of y comma x and x comma y is same, equal. So this one you can also write s comma y and y comma x. So this is both the same. So we got again the same formula. This is simple way we can prove the variance of s plus y is equal to. Here it is a covariance of x. This is variance of x plus variance of y plus 2 times covariance of s comma y. So this is simple way we proved the variance of s plus y is equal to variance of s variance. Now it is variance of s. So x and y are independent. You can say independent. X and y are independent. Then what will happen? X and y are independent means this covariance of s comma y is equal to 0. If x and y are independent means covariance of s comma y is equal to 0. So this term is become 0. So if it is x and y are independent, we can write variance of s plus y equal to variance of x plus variance of y. If x and y are independent, covariance of s comma y is equal to 0. So this will become variance of s plus y, variance of s plus variance of y. So we understood about the if s and y are independent. Same way, the same formula we can write. This is a covariance of variance of s minus y. This instead of s plus y, variance of s minus y, we can write this is a variance of s plus variance of y minus of covariance of x comma y. Variance of s, variance of y minus of covariance of s comma y. That will be a variance of s minus y. So instead of y, we are giving minus y. So it will get a minus of 2 times covariance of s minus y. We can check variance of s minus y. If we are giving s minus y here, so this is become s minus y. This is also become s minus y. So here covariance of h, there is no y term, and covariance of x and y. So here it is a minus. And y, this is a minus covariance of y and x. Here is both are minus. So formula will be getting covariance of x. Here is covariance of y. This is both are minus. So here it is plus covariance of y. And here is a covariance of s minus y. So we got the here it will be minus of covariance of s comma y and minus of covariance of s comma y. This is we can write a y comma x. This is the same, both are same, y and x is same. So this is become 2 times covariance of s comma y. So variance of s plus variance of y minus of 2 times, this is become 2 times of covariance of s minus y. So this is a variance of s minus y. If it is independent, if x and y are independent, then variance of x minus y is equal to variance of x plus variance of y. There is no covariance terms. Covariance term is 0. So if it is independent, if you want to see the variance of s minus y, variance of s plus y, it will be both are same. When it is independent, we have to add. Just adding variance of s plus variance of y is equal to the variance of s plus y or variance of s minus y. Both are equal when it is independent. So that is the basic of the variance of sum. We can do some problem, solving some problem, we'll understand. We can write here variance of s minus y is equal to variance of x plus variance of y minus of 2 times covariance of s comma y. So this is two formula we studied here. Now is a problem, solving the problem. S is a Poisson distribution. So we are now solving the problem. S is a Poisson distribution of 5, mean is equal to 5. And y is the Poisson distribution of 10, means equal to 10. And we given the covariance of x and y, that is equal to minus 12. Now z is equal to defined x minus 2y plus 3. Z is defined, Z is a third parameter, random variable. Z is defined, Z is equal to s minus 2y plus 3. Calculate variance of Z. Calculate what is the variance of Z. Variance of Z. What is the variance of Z? So this is a question. S is following the Poisson distribution 5. Y is following the Poisson distribution of 10. Mean is equal to 5 and mean is equal to 10. Covariance of xy is given and Z is x minus 2y plus 3. So we can write the formula for the Z, variance of Z. So variance of Z is equal to, so variance of Z, instead of Z we are writing the x minus 2y plus 3. So this is x minus 2y plus 3. Instead of z, we have written here x minus 2y plus 3. So this is what will be formula. This constant in terms of here in the variance, constant is equal to 0. So we no need to take the constant. Constant is become 0 only. So it is become s minus 2y. S minus 2y is equal to. So s minus y, we know the formula. Same way we can write is a variance of x plus variance of 2y. Variance of 2y. So this is minus 2y. Variance of minus 2y. And minus of 2. Minus, if you are taking the minus, we don't take here as minus. So it is a minus already we have taken here. Then we have taken x and y only. So minus already taken here. So minus of 2 times covariance of s comma 2y. Two way we can write here. This is a variance of x plus minus 2y. This is a one method. Then we have to use this formula. Variance of s plus y. In this method we have to write like that. Variance of x plus variance of, in this method it is a minus of 2y. S plus y. Variance of 2y minus of 2y. Plus 2 times the covariance of s comma minus of 2y. We have to write like that. So this is one of the method, s plus y. So s plus minus 2y. Then we have to put the minus 2y in all the places. Here we are directly applied the formula x minus y. So it is a minus of 2 times covariance. So this is a variance of x. This is variance of 2y. 2y we can get 2 is taking outside is a 4. Variance if we are taking 2x is taking outside, constant is taking outside, is become 2 square. So it is become 4. So here is x into 2y. 2 you can take outside. 2 into 2. So this is become 4. 4 covariance of s comma y. Same way here also variance of x. This is a 2 square we have to take outside. So what will happen? Plus 4. Here is minus 2 we need to take outside. So it is a 2 in multiply is minus 2. So that also it's become minus 4. Minus 4 covariance. To both method we can, x minus y we can take this formula directly, or variance of s plus y. First formula. In case of s plus y is taking, it will become minus 2y. Then we can directly apply. So variance of x, you know the variance of x is equal to, mean is equal to 5, variance also will be a 5. So this is a 5 plus 4 into 10 minus of 4 into minus 12. 4 into minus it's become plus, and we will get the, this is a 45 plus 40. This is equal to 93. This is equal to 93. We got the 93. So this is one small problem. Same way here it is, a formula is given. Poisson 5 means variance also 5 only, and variance also 10 only, y, and we substitute covariance of xy is given minus 12. So it's just substituted here. We got the 93. One more formula, one more case we can discuss here. In random variable x and y are jointly distributed with a standard deviation. Standard deviation sigma x is given 5 and sigma y is given 7. So this is x and y are jointly distributed. Sigma x is equal to 5 and sigma y is equal to 7. And correlation, we given that correlation of x comma y is equal to minus 3 divided by 7. Correlation is given. Calculate standard deviation of z is calculating 3x minus 2y plus 5. So this is the formula. You can write as a z, standard deviation of z. We need to find out the standard deviation of z. So the same formula we have to apply here. So same way we can write. First is a correlation of x comma y. So we need to find out first covariance of x comma y. So correlation of x comma y, this one we can write covariance of x comma y divided by root of variance of x and variance of y. So that is a minus 3 by 7. Variance of x is given, it's a 5. So this is variance of x is equal to 5 square. Standard deviation is given, sigma x is equal to 5. So variance is equal to 5 square. So variance of y is equal to again 7 square. So 5 square is 25 and 7 square is 49. 25, 49. This is getting 1225. 225. So this one root of 1225 will get 35. 35. So covariance of xy, covariance of x comma y is equal to, is multiplying here, minus 3 divided by 7 into 35. So it's a 5 times. So it is a minus covariance of x comma y is equal to minus 15. Covariance of x comma y is equal to minus 15. So even there given the correlation of x comma y is equal to minus 3 by 7. We find out the covariance of x comma y is equal to minus 15. Now standard deviation of z. So variance of z, first we need to find out the variance of z. Variance of z, first we need to find out variance of z. Instead of z we are just substituting 3x minus 2y plus 5. So here it is 5 is constant, it will not affect here, it is 0. So 5 is just removed. So variance of 3x minus 2y. Variance of 3x minus 2y, we can apply this formula or this formula, same way. We can apply here or here, both places we can apply. X minus y, same way we can apply here. X minus y, so this is, we can just think about x minus y. So variance of 3x. This is x is 3x and y is 2y plus variance of 2y, variance of 2y minus of 2 times covariance of 3x minus 2y, 3x 2y. If we are applying s plus y formula, what will happen? X minus s plus y formula. If you are applying variance of s plus y formula, then how to write here variance of, we can write s plus y formula. So we have to write like that, variance of 3x plus minus 2y. You have to change here like that. So we can apply s plus y formula, variance of s plus y. Same way we can apply 3x like that, we can apply same formula we can apply here. 3x plus variance of minus 2y and plus 2 times covariance of, we are applying here this formula only, covariance of 3x minus 2y, you can apply like that. So here is variance of 3x, variance of 3x, what will get variance of 3x, that is equal to 3 square of variance of x, 3 is taken out, here is variance of 2y, 4 of variance of y. Minus of 2 times, this is 3 into 2, 3 has to take out, 3 and 2 is taken out, and a covariance of x comma y. So this is same. So what will get, this formula we have just modified here, 3, so 9 variance of x. 9 variance of x is a 5 square, variance of x we can write 9 into 5 square plus 4 into 4 multiplied with the variance of y, this is 7 square, minus of this is 6 plus 2 minus 12, covariance is minus 15. So this is getting 9 in 25, this is getting 601. So standard deviation is the root of 601. You get the standard deviation is root of. So this is a root of, here also this is same, 3 square variance of x minus 2 square. So 4 variance of y. Here if you are taking here, it will be this formula. If you are modifying this formula, what will happen? Here we have to write like that. Plus 2 minus 3 multiplies minus 2. So this is become minus is written here minus. Same way. Then we are applying variance of x, variance of 601. So square root of 601 will get the answer. It's approximately 24.5. So this is the variance of sum. We find out the variance of s plus y is equal to variance of s plus variance of y to covariance of sy. Even it is independent, this term is become 0. So if you are taking the random variables difference also plus also some same variance of s plus variance of y. When in the case of x and y are independent. Thank you.